If there really is extraterrestrial life in the universe, how should we tell them where Earth is located? When we zoom out far enough, we can see that the galaxies in the universe form an obvious fibrous structure, with these thick fibrous strictures arranged in a linear pattern. Although at a large scale, these are very small filaments. They are all strictures composed of large galaxies, with many galaxies present on each filament. The denser areas where these galaxies are combined are known as galaxy clusters. Among the many fibrous strictures, there is a very famous large-scale filamentary structure, the Laniakea supercluster. This is a very large cosmic structure composed of approximately 100,000 galaxies with an astonishing range of 520 million light-years. The entire Laniakea supercluster is like a huge cosmic web, with the fibers that make up the cosmic web composed of galaxy clusters, and our Milky Way is located on one of these filaments. Surrounding these filaments are huge cosmic voids where there is almost nothing. Within the Laniakea supercluster, there are multiple galaxy clusters, such as the Hydra cluster, Centaurus cluster, and Abell 3565. We are located in an irregular galaxy cluster called the Virgo cluster. There are approximately 2,500 galaxies in the Virgo cluster, covering an area of about 100 million light-years. Of course, even if we find the Virgo cluster, it is still very difficult to find our Milky Way. According to current astronomical observations, the central region of the Virgo cluster is about 60 million light-years away from our Milky Way galaxy. Therefore, we can search for the image of the Milky Way within an area about 60 million light-years away from the Virgo cluster. Within this galaxy cluster, there is a galaxy group called the local group, which contains about 50 galaxies and covers an area with a diameter of about 10 million light-years. Within the local group, there are two larger galaxies that are about 2.54 million light-years apart. The larger galaxy is called the Virgo galaxy, which is a spiral galaxy with a huge disk structure and a diameter of about 220,000 light-years, containing about 100 billion stars. The other smaller galaxy is our Milky Way, which has a diameter of about 120,000 light-years. Of course, even if we find our Milky Way, finding Earth is still very difficult. After all, even a sun that is 1.3 million times larger than Earth is insignificant in the Milky Way galaxy. There are at least 200 billion to 400 billion stars in the Milky Way galaxy. Our Milky Way is a barred spiral galaxy with an elliptical disk shape and a huge disk structure. The Milky Way has four fairly symmetrical and clearly defined spiral arms, which are about 4,500 light-years apart. Most of the stars in the Milky Way are located on these four spiral arms, except for the central stars. Fortunately, our solar system is not located on these four spiral arms, but on a spur called the Orion Arm, close to the inner edge of the Milky Way, about 26,400 light-years away from the center of the Milky Way, and rotating counterclockwise. However, there are still many stars in the Orion Arm, so it is not easy to find the Sun. But we can use nearby star systems to locate the Sun. In an area more than 4.22 light-years away from the Sun, there is a triple star system consisting of two yellow dwarfs and one red dwarf. The two yellow dwarfs are very close to each other, with a minimum distance of only 16.8 billion kilometers, while the red dwarf is very far away from the two yellow dwarfs, about 0.2 light-years away. Therefore, as long as we find this triple star system within the constellation Orion, we can see the existence of a yellow dwarf star within the region of 4.22 light-years away from this triple star system. This yellow dwarf star is approximately 4.6 billion years old, which is our solar system. Once we find the solar system, finding the Earth is very simple. There are 8 planets around the Sun, one of which is our Earth, located 150 million kilometers away from the Sun. We have completed the task of finding Earth in the universe. However, in the real universe, it is almost impossible to find Earth. Firstly, due to the limitations of the speed of light and cosmic expansion, the human vision is limited to the observable universe. Even if we have the most powerful telescope, we cannot see the edge of the universe, because the information beyond the region more than 46.5 billion light-years away from us can never reach the Earth. Therefore, we can only communicate with extraterrestrial civilizations within the observable universe. The galaxy clusters we know, such as the Laniakea supercluster and the Virgo cluster of galaxies, are all observed using telescopes. we still do not have a clear understanding of their positions and structures in the universe. Therefore, even if we tell extraterrestrial civilizations that we are within the Laniakea supercluster, they may not know what it is. The universe we see from this tiny Earth is only the tip of the iceberg of this vast universe. The real universe far exceeds our imagination. Earth is insignificant in the universe. Perhaps finding a planet like Earth in the vast universe is much more difficult than finding a needle in the Pacific Ocean.
Let us know in the comments section what you liked about this video or what you'd like to see next time we make it. We read every comment carefully.